So I'm going to do one more here. I want to solve the equation sine of 2 theta equals negative root 3 on 2 for theta as an element of negative pi and pi. So I'm going to let x equal 2 theta. Okay, so I'm solving for x. So if theta is an element of negative pi to pi, then x being 2 theta is an element of negative 2 pi to positive 2 pi, that should be. Let's just whack a 2 in there. Okay. So the equation we're actually solving is sine of x equals negative root 3 on 2 for x being an element of negative 2 pi to 2 pi. I'm going to do it in, this is actually the worked example in the book, but I'm going to do it a slightly different way to the book. That's back in focus. I'm going to do a slightly different way to the book. What I'm going to do is I'm going to work with the first quadrant equivalent for a start. So that's meant to be an a. If the sine of a is root 3 on 2, then a is pi on 3. Okay, and that's from this here. This is from my table here. So if you look at pi on 3 here, the sine of pi on 3 is root 3 on 2. So the equivalent angle is 60 degrees or pi on 3. So if we go to our unit circle, what I've done here is I've drawn in pi on 3. This is theta, it's pi on 3. So this is the first quadrant angle. Okay, and but what we actually want is we want the times where sine equals negative. So the sign is the negative. Okay, so this is A, S, T, C. Okay, and so the sign is negative in this quadrant and this quadrant. So we're working in the third quadrant and the fourth quadrant. Quadrants number 3 and 4. Okay, because if that's positive, if that sign is positive, that sign is negative. So what we want is we want the value of this angle, because it's also equivalent here. That's negative, what did we say it was? Sorry, negative root 3 on 2. This is negative root 3 on 2. This is negative root 3 on 2. So we want this angle and we want this angle. So if our circle here is between 0 and 2 pi, then what we want is well, what's this angle? This is pi. This angle is pi plus pi on 3. So this is actually 4 pi on 3. So that's one of our solutions. 4 pi on 3. And this one is 2 pi minus pi on 3. 2 pi minus 3, and that equals 5 pi on 3. So they're the two solutions between 0 and 2 pi. Okay. Now, what we also want is we want the solutions between 0 and negative 2 pi. So what we're actually doing now is we're just going back in the other direction. So if we go in the negative direction, this angle here, it's still the same point on the circle. This is negative pi on 3. Okay, because we've just gone back that way, pi on 3. And then to get around to here, we just go another pi on 3. So this is negative 2 pi on 3. So what I've put in the boxes there are 4 solutions. There are 4 solutions to the equation between negative 2 pi and 2 pi. And what we do when we write our solutions to this is we write them in order from smallest to largest. So our solutions are negative 2 pi on 3, then negative pi on 3, then what's next? 4 pi on 3, and then 5 pi on 3. Okay, there are solutions to the equation being sine x equals negative root 3 on 2. So that's similar to the worked example there. So they're the required solutions for x. Now, given that x equals, let's move this up, given that x equals 2 theta, theta equals x over 2. So if you want the solutions to the original equation, what you've got to do is you've got to take these 4 solutions and half them. So I'll do that on this piece of paper. We'll do that there. Okay, so let's write it out. Our original solutions are negative 2 pi on 3. Okay, then you've got negative pi on 3, 4 pi on 3, 5 pi on 3. Okay, now if you want to divide all of those by 2, you can actually just double this bottom number here. So this becomes negative 2 pi on 6, negative pi on 6, 4 pi on 6, and 5 pi on 6. Now 4 pi on 6, we can simplify that fraction back to 2 pi on 3. Okay, so they are the 4 solutions to the original equation. Okay, if you have a look at the worked example in the book, it's the same example, but they have used the function itself to solve it, whereas I've actually used the unit circle. And you can use either, so I recommend you have a look at it and just see how you can make that fit. Okay, I think I'm going to stop the video now. I've shown you what I need to show you, but have a go at the exercises. As always, ask your teacher if you've got any questions, and just take it from there. Thanks.